The angle measure, okay? Today is talking about how we measure and classify angles, so how we name them, okay? And we identify and use congruent angles and bisectors of an angle, okay? We'll get to that at the very end. Yes. Okay. Some vocab for angles. We have a ray. We've talked about lines. We've talked about line segments. Now we have a ray. What a ray does, it extends infinitely in one direction. So it has what we call an initial point. Okay, that's the point where it starts, and then it goes forever in one direction. Right, that's different from a line because a line goes infinitely in both directions, right? And a line segment has two endpoints. Okay, a ray has an initial point, okay, and goes on forever in the other direction. So we use, for example, if this was ray DF, just like that says, we call DF with a ray over the top of it. Now that's different from, remember when we talked about line segments, like if we had line segment AB, we just put the bar over the top of it. Or if we had, line EF, we put the line over it. Okay? We always use 2 points to talk about line segments, lines, and rays. And when we're talking about a ray, we just put a bar over the top with an arrow going in one direction, because a ray goes forever in one direction. So you can't measure a ray just like you can't measure a line. Okay? Opposite rays, okay, opposite rays are two rays that make up a line, right? So their initial points right here, they share that. They go in opposite directions. Okay? Here they're also called collinear rays. They share a line. Okay? So this makes up a line, right? This figure right here is a line, but it's actually two rays that have an initial point right there. Okay? Those are what we call opposite rays. And the reason we need to know what rays are, because they form the sides of an angle. Okay? When we have an angle measure, the two sides of it are rays. And the vertex is this point right here, the point where they meet. And that's the initial point of the ray. We have a blue ray, get it? Okay. So we have a ray going off this way, okay, and a red ray going this way. These form an angle. Okay? So two rays meet at this initial point called a vertex. That's what creates an angle. Okay? So now we know line segments, line, rays. Or opposite rays are two rays that lie flat and then collinear, they make a line. Okay? And then two rays together that share an initial point like this form an angle. Again, how we call angles, okay? Again, this is the vertex, the point where they meet. We can call angles several different ways. One way is we just call it by its vertex. Okay? This is angle A. I'm talking about this whole angle right here. Okay? That's just angle A. Another way we can call it is we use 3 points, but the middle point always has to be the vertex. So we could call it BAC or CAB. As long as that middle point that you're talking about is the vertex, you can call it with 3 points. The reason it's important to call it with 3 points is because we start getting these crazy big figures. So then we have to start using 3 points to determine what angle are we talking about. Okay? But it always has to be the middle point, always has to be the vertex. Okay, always has to be that right there. Or we could also call it with the number that's inside the angle, in this case angle 4. So this is how we name angles. So we name them with 3 points most of the time. Just like lines, line segments, and rays we name with 2. Here we name with 3. Or you can name it with 1 with just the vertex or just the number. Okay, that's how we name an angle. So just like we said, it can be named using a number or 3 points on the angle. So what's one way I can name this angle here? Yeah, Eric. Angle H. I can name it by just its vertex. Right, that's one way. Yeah, Carson. Angle GHJ, right? As long as the middle point is that vertex. Okay, that works. What's another way?
1.
Angle 1. And what's the other one?
JHG.
Good, JHG. Okay? The order doesn't matter. The middle one just has to be the vertex. Okay, that's when we name an angle. So here I want to name all the angles that have point B as a vertex, the point where they meet. There's 4 of them here. Okay? And you can name them however you want. Let's start rattling off those 4. Yeah, Carson. ABD, that has B as a vertex. That is correct. That's that angle. Yeah. GBA, angle GBA has B as a vertex. Right? GBE, correct, has B as a vertex. So the last one is, you can either call it good. You can call it FED, or you can call it EBD, okay, or DBE. Doesn't matter which of these points you use because they're all on the same line. Okay, so all of those have point B as a vertex. We could have also said angle 7, angle 5, or angle 6. Okay, but I would most often name it with 3 points because that determines exactly what angle you're talking about. Because we start getting bigger figures where if you say angle 5, you don't know which one you're talking about. Okay, so getting a good habit of naming with 3 points makes it a lot easier. Very good. Okay. Name the side of angle 5. So angle 5 is this one right here. Okay. So what's one side of this? What? Yeah, Jeff.
G.
G. We have to name with 2 points though. Remember. So like GB, right? Ray GB. Okay. And actually, we should probably normally start with the initial point. So call it Ray BG, like the band, right? The BGs. Ray BG. Okay, at the ray. The other one, the ray, we could call BE or BF. Those are the same rays, right? Those are the sides of that angle 5. Okay, those are those sides. What's another name for angle 6? Well, we just said that. Another way we could call it was DBE or DBF or FBD. Or EBD. Okay, those are all other names for angle 6. You guys seem to pick up that pretty quick. Okay. So looking at this, look through these options. Which of these angles has X as a vertex? Now you can look at the angles in the picture, but you can actually tell just by running through these options. So I'll give you a second to think about that. Which of these has angle X as a vertex? So one way you could go through and look at all these angles, you could look at X, B, Y. You could look at Y, X and go through. But I know, what's the answer? D, right? Good. Because the middle point has to be the vertex when you're naming angles. So the vertex of this one is A. The vertex of this one is A. The vertex of this one is B. I know the vertex of this one is X because the middle point has to always be the vertex. Okay. Just like before, which ray is a side of angle 3? Okay, and here we would call it XN because that's this ray right here. Oops, sorry, Carson. The reason we wouldn't call it RA is because RA goes from here to here. That's a line, not a ray. Okay, if we said from R to A, that ray here, it goes a little too far. We would have to call it XA. Okay. And another word for angle 3, or another way to name it, NXA, right? We could call it NXA. We could have also called it BXA or AXB, okay, and so on. So that's the main part of the assignment is saying give another name for this angle. Give another name for this ray. Okay, those sort of things. The quiz isn't over this stuff. The quiz is over the homework assignment first. But you will have a quiz over this stuff probably later next week. Yeah. Name the sides. We did all this. We don't need to go through this. Here, last thing before lunch, and then we just got 1 or 2 things to go over. Interior point and exterior point. Interior means inside. Exterior means outside. So what would be the interior point in this angle? X, right? It's on the inside. The exterior point would be Z. All right, very good. Figure we know that. We should probably go over. Then we classify angles as either right, acute, obtuse. How many have seen these before? Yeah, good. Okay, right, acute, obtuse. Right angle means it's 90 degrees. It's the corner of a square, like a corner of a room. Right, so like if you're cold, you should go over to the corner of a room because it's 90 degrees. Right, remember that? Okay, yeah, okay, right. And then acute angle is less than 90. Obtuse angle is greater than 90. Okay, so those are the 3 ways we classify these angles. And when we come back from lunch, I'm going to show you with a protractor how to measure these angles. This is a protractor right here, right? I'm going to show you how to measure angles and determine what degree measure they are. Okay, all right. And we'll start with this one. First I want to talk how to use a protractor. Okay? So given an angle, how to measure it with a protractor. In this case it says measure angle WYT. So that angle would be this one right here, WYT. How to measure that with a protractor. So if you have a protractor, I'll kind of hold up here, you can kind of see. There's a little space in there where there's those crosshairs. Okay, that's where you put the vertex. So just in this picture here, that little hole there we put on the vertex, which is Y. Okay, and then you line up one of those crosshairs with a ray. Okay, or this side here. The other side, the other ray, then crosses that protractor, and you read where it crosses. So it says 50 on top right there, and it says 130 on bottom right there. Why does it say both 50 and 130? Yeah.
In case like you want to measure SYT.
Exactly, because you could measure SYT doing the exact same thing. Well, how do I know how much this blue angle is? Is it 30 or is it 150? Or sorry, is it 50 or is it 130? It's probably 130, right? Because it's clearly bigger than 90. Where this angle SYT, that's the 30-degree measure. Because see, it's still lined up with those crosshairs here, and its vertex is Y. So you'll see on the protractor, it always has, 90's the same whatever direction you go. But then it has 70, 110, 60, 120, 50, 130. You just kind of have to look. If it's bigger than 90, it's the bigger number. If it's smaller than 90, it's the smaller one. Okay? So that's how we use a protractor there. In this case, measure angle TYW. TYW. Okay? It looks like, and for those of you in the back probably can't see, there's 40, there's 50, so it's right in the middle of those. So it's probably 45 degrees. Yeah.
Is it TYW on the other side?
Yeah, because I level TY, or no, sorry, I said TYW, it's TYU though. I said one thing and did the other. TYU would be TYU, okay? So that'd be about 45 degrees. So again, we'd go over these and we'd measure it. In this case, when you angle CZD, okay, it's clearly over 180. Okay. That's 150, so it would be obtuse. Obtuse is larger than 100 or larger than 90. Okay, we don't need to go through all these. And last, we have congruent angles. Just like when we have congruent segments, we put those little tick marks on them. When we have congruent angles, we put these little marks inside them. So these two angles, angle NMP, is congruent to angle QMR because they're both 25 degrees. And we put that little angle symbol in front of them when we're talking about angles. So that's angle NMP, congruent to angle QMR. If an angle's bisected, just like when a segment's bisected, what's bisected mean? What's it mean to bisect something? Cut it into two equal pieces, right? We bisect it. So this little ray mark should be scooted over a little bit, right about there, okay? That's ray AB. This ray right here bisects VAW, bisects this whole angle. So since I bisected that whole angle, that means these two angles themselves are equal to each other, right? These two angles would be congruent because I bisected that whole angle with this line here. So if this angle's 10x minus 20 and this angle's 8x minus 10, and I know they're equal to each other, to solve for x, I just need to set them equal to each other. I know they're equal because they're bisected, right? 10x minus 20 is equal to 8x minus 10. I know that those two are equal because the problem tells me this ray bisects that whole angle. And then I would just start solving that for x. I'll move that 8x over the other side. I get 2x minus 20 is negative 10. Add 20. 2x is equal to positive 10 divided by 2. So x is 5. Okay. Again, I know that because these two are bisected. So they're the same because I bisect them with that ray AB. Sure. Okay. So this is going to be the last one we do. Long problem, basically saying that find the measure, and when we say we put the little m when we talk about the measure, so find the measure of angle GBH, and I'm just going to highlight that one. That's that one right there. And HCI, which is that one right there. If those two angles are congruent to each other, and GBH is 2x plus 5, and HCI is 3x minus 10. Well, it tells me those two are congruent to each other. So if I have each of their measures, what am I going to do between those two? Set them equal to each other because I know those are two equal angles. 2x plus 5 equals 3x minus 10. You do some algebra there, and you get x is 15, right? Subtract that 2x over there. You get 1x, add that 10 over there, you get 15. So x is 15, but the problem asks, find out what measure of angle GBH is. So now that I know x, how do I find GBH? Plug it in, right. I'm going to plug in x there. 2 times 15 is 30, plus another 5. That would be 35 degrees. And I should get the same thing here when I do it. When I plug in 15 there, I get 3 times 15 is 45, minus 10 is also 35. Yeah. So those two are equal to each other and both 35 degrees. I found X and then just plugged it in. This problem's very similar, so we're not going to go through it so we can get to the quiz. Okay, but you would do the same thing. Okay? And that's the end of angle measure.